Go. So we're gonna look on resolving vectors. So we're looking on resolving vectors. And before we look at resolving vectors, let's look at what a vector is. So a vector has size and direction. Let's represent a vector. If I have a vector, let's call it A. Say call this vector A, and let's call this vector B. Notice that vector A and vector B we use let's put some values here. Argument's sake this is equal to 10 newtons, and for argument's sake this is equal to minus 2 newtons. Notice that the length here, although it's a sketch, it's shorter than this one here. So we know that, hey, 10 newtons would need to be bigger than 2 newtons. And we also use this negative here to give me an indication of my direction. Also, arrows with arrowheads are used to give us direction as well. So that's one of the first things about vectors. Afterwards, there is this, or should I just give me a second, let me get me a new page. Give me a second. Oh, I should have used my hand. Let me get my page function up. Okay, both of you guys are competing for the same position. Alright. Page 2. Alright, we can look on what we call resolving vectors, or let's look at what a resultant vector is. Let's look at an example. Let's look at that same vector A and B. So we have A, and we know it's equal to 10 newtons, and we have B, and we know that it would have been equal to 2 newtons. We can draw a single vector let's call this our resultant, would have been A plus vector B. They're heading in the same direction, and we have 10 plus 2, and we'll end up with 12 newtons. Now these two vectors will act as the same as the single vector, and this vector is called a resultant vector. So it's called a resultant vector. I said first, same thing under this condition. Vector is a single vector used to represent two or more vectors. And that's easy. In this example, when we have these two vectors here, let's say A, vector A, and vector B, we consider these to be in the same plane. So they will be in the same plane. So they'll be coplanar, and they will be at 0 degrees to each other. So they're acting in the same plane. To get the resultant, we would, let's call it R, we would add A plus B, and we'll get our resultant there, which is going to be easy. What if I had vector A and vector B? Now, based on definition, under normal circumstances, going from, we call negative 2, going from left to right, we normally give that a positive. Going from right, so we're right to left, we normally give that a negative. And I could still add, I could still use the same formula to get my resultant vector. A plus B. A is this plus minus 2. Sorry, I'm supposed to write minus 2. And I end up with a resultant vector of 8. So we know we would actually have a vector going this direction with a resultant of 8 newtons. And that's how we look on two vectors. So this is one scenario where the two vectors are going in the same direction. This is another scenario when the vectors are acting in opposite direction. These two vectors are coplanar, but there's a difference here. These two vectors are considered to be at 180 degrees to each other. Other should go here, and other should go there. There's another scenario. Give me a second. Should get another page. I don't want my page to come up. Why are you giving me trouble? Okay, good. There's another scenario. What if I have two vectors? We're at a point here, and one is acting this direction. Let's call this A as well, and it has a value of 3 newtons. And we have another vector here, and let's call it B, and this vector is actually 4 newtons. Our resultant vector is gonna be not hard to find out. It'll be heading in this direction here. And we're going to use what we call a parallelogram diagram. So what happens is that whatever is on this side is also on this side, and they are equal. So if this is 4, this is 4. And this is 3 on the bottom, this is 3. This is going to form a nice right-hand triangle. And that would be our resultant. So that's going to be our parallelogram. Later on, we're going to talk about resolving vectors using theoretic method, but we're using calculation. So based on Pythagoras' theorem, let's draw this triangle here that we just formed. Say that we have our angle here, call it theta. This would be our hypotenuse. This would be my opposite to the angle, and this would be my adjacent. Based on Pythagoras' theorem, r would have been equal to r squared would have been equal to a squared plus b squared, and r would have been equal to the square root of a plus a squared plus b squared. Therefore, a would have been equal to 3 squared plus 4 squared, and this would give me 9 plus 16, and we're going to end up with 25 squared. Therefore, r is equal to 5 newtons. So this is a scenario. So if two forces are at 90 degrees, we can solve it using Pythagoras' theorem, and that's our example there. Give me a second. Alright. Alright, so let's move from that and look at an example of how we could resolve this. Alright, so let's look at something easier. Let's find the resultant forces for the following. 1, 2, 3 examples. Let's make example 1 Easy. So let's call this F1 equal 5 newtons and F2 equal to 3 newtons. My resultant would have been, let's put this negative 3 here, F1 plus F2, and we'll actually have 5 plus minus 3, 3 minus 3 is equal to 2 newtons. Let's make raise 3 for more space, and let's make this one a little bit more difficult. Let's say I have a force going upwards. So you F1, let's make you 1 newton. I have a force going downwards, call it F2. Let's make you 1 newton as well. I have a force going this way. Let's call you F3. Let's make you 3 newtons. I have a force going this way. Let me call it F4. And let me make you 1 newton. And I'm gonna add another force here. Let's call me F5. And I'm gonna make you 2 newtons. Now, under these scenarios, we're gonna consider equal and opposite forces. Well, equal and opposite forces, or opposite forces. So these two forces are acting in the same opposite direction, or in the same plane, and these forces here. We're gonna look on another concept called vertical. Let's look at vertical, and vertical means that we're going up or down. So let's look at vertical result. So that's gonna be F1 plus F2, and I think I'm gonna put some negative sign there to help you. It's gonna be negative. That's gonna be negative. So let's look at F1 plus F2. So F1 is 1 plus negative 1. Therefore, the object is not moving upward or downward. Let me go up here and erase this portion here. So I can do this portion. Let's look at horizontal. When I look at horizontal, I like to think about the horizon. So it's gonna be horizontal. And horizontal are gonna consider these forces. Forces that are going in this direction, we're gonna give them a negative. And forces that are going in this direction are gonna give them a positive. So let's look at horizontal. We can say that we have a force of, let's call it F5 is going that direction, plus F3 plus F4. Let's put in our symbols. This is going to be 2 plus 3 plus minus 1, and that's going to be 5 minus 1, and therefore we're going to have a resultant force of 4 newtons. If I was supposed to draw that, and I'm going to look at the direction of this object, or normally a block in physics, is we're moving with a resultant force in this direction of 4 newtons only. We won't be seeing it moving upward, we won't be seeing it moving downward, we won't be seeing it moving backward. All we're seeing the moving is in that direction only. And that will look on some basic example of resolving forces. Next video we're going to let's look at some components of vectors using horizontal and vertical components.